All right, so today we're working on more regression stuff, nonlinear stuff. I will tell you, in the past when we taught this lesson, you had to do all this fancy testing to determine which was the best fit, and we're not doing that this year. On the quiz, it just tells you which one to use, okay? So that was first I have a warm-up on Newton's law. Can anybody tell me where any of this goes in? You could do this one, write it down, just talk me through it, whatever you want. Nope. Anybody tell me what 68 is? Yes, it's the surroundings or the medium. Oh yeah, this does have M. And I think it might on the quiz. Remember I talked about it yesterday that I wasn't sure which it was. It really works much better if you turn the tablet on first. Or if it's dead, we could just cry. Dropped my tablet yesterday, but it was working after that. Okay, maybe we're all right. All right, so this is the surroundings or the medium that it's in. It's the same difference. What is this? Yep, for all parts, that's the original temperature. It cools to this, that's our final temperature temporarily, in 14 minutes, that's our time. How long will it take till it gets down to 100? This we only need after we find the cooling thing. This is for part 2. All right, so the final temperature at the moment is 200 minus the room, which is 68. The original temperature was 325 minus the room, which is 68. E to the negative, we're trying to find K, and T is 14 minutes. Okay, what is this, guys? 132? This is, I have no idea, 257. And I'm just going to rewrite that as negative 14K. All right, what's next? Okay. Then what's next? Okay, so I end up with a log of 132 over 257 equals negative 14K times ln of E, which is just 1. So I type this in, and then I divide it by negative 14. Somebody got a decimal for me? Guys, you don't do homework and you don't pay attention to warm-ups? Really? Thank you. All right, now we have to plug it back in and find the time to 100 degrees. This is right off the quiz. It says from the time it's taken out of the oven. So we're no longer using this 14 minutes or this 200. We're trying to find this to get down to 100. So we go back to the formula. The temperature we want at the end is now 100. And it still started at 325. Now K is 0.0475 and we're looking for T. So what do I do first? Okay, I get, is this 32, guys? Okay, this is still 257, right? Okay, so then I'm going to have 32 over 257, and I'm going to take the log of both sides. So I'm going to get this number, and then I'm going to need to, what? Yeah, because this moves out front, so I need to divide. So someone find me that answer. So around 44 minutes. Okay. Anybody else getting that? Not getting that? Yes? Okay. All right. Any questions about Newton's law? All right. I'm a little more worried about this problem because rounding matters. There's a question like this on the quiz. We started talking about one like this yesterday. It says a single-celled amoeba reproduces every 6 hours. In other words, the amount doubles, okay? Every 6 hours. So H, how long until it does something, is 6 hours. Doubling is the rate that's going on. If 100 such amoeba are placed in a petri dish, so this is our original amount, find the amount, calculate the amount of time to the nearest tenth of an hour needed for the population to grow to over 10,000. Okay, if we round down, is it going to be over 10,000 in the dish if it's doubling? Do you understand what I'm saying? We have to round up. It says to the nearest, but it's really to make it go over 10,000. So you're going to have to check at the end of the problem that it went over 10,000. So what's the equation? But nobody needs to do homework. Can you look at your pink sheet maybe? Isn't it T over H? So it's T over 6, okay? And we're trying to get it up to 10,000. Now what? Can I do 100 times 2? No, because this has an exponent. I have to divide the 100 over here, which gives me 100. Somebody check. Is that right? 10,000 divided by 100? So I have 100 equals 2t over 6. Then what? I have to do log of both sides. So now I have log of 100 equals log of 2, which doesn't cancel, right? Can I move that? Of course not. I want to bring that exponent out in front. So I have t over 6 times the log of 2. Now what? Okay, we could divide this by log of 2. I'll get rid of it over here. So if someone type log of 100 divided by log of 2, you're going to get a crazy decimal. Okay? Da 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 da. Equals t over 6. Using that whole decimal, we still need to do what? Multiply by 6. And we get? Okay. It would round up either way, right? But if this had been 39.81, you're still going to have to round up to 0.9. And I'll show you what happens in a minute. It says to the nearest tenth of an hour, because we have to put this back in. It says, after rounding to the nearest tenth, calculate how many actual amoeba over 10,000 are present. So we started with 100. It's doubling. We're saying our time to double is 39.9 divided by 6. Is that what we want? How many amoeba are in the dish? What does it say? How many over? So we're hoping this goes over 10,000. So type that in. Okay, we need a positive answer. How much do we get? Okay, so you didn't subtract the 10,000 yet? Okay, so when we subtract the 10,000, we have like 43 extra amoeba. It says around to the nearest amoeba. Yes, no, maybe we get it. If you had put, say, 39.8, can someone do 39.8? Is it over 10,000? No. So then you would know something's wrong and you just need to go back and round it higher. Does that make sense, guys? If it doesn't go over the 10,000, then you haven't let the time go far enough. All right, so you're good on one like that on the quiz? Thinking you should do some homework. Okay, the kinds of modeling we're going to talk about today are exponential, logarithmic, logistic. Okay, so exponential, growth or decay looks like this. Logarithmic growth or decay. What's the difference, guys? How is this growing compared to how this is growing? What's the rate at which this is growing versus the rate at which this is growing? Yeah, this grows fast, right? Logarithmic growth grows very slow. All right. It also, has different points, etc. But all right. So the first question we're going to do is about the gross domestic product in the years since 1950. And we're supposed to find an equation, then an estimate for 2020. All right. So I want you to type these in. What do we do when it says years since 1950? Yeah, we take off 1950 from all of these. So we're going to make this 0, take off 1950. We get 10, 20, 30, 40, 50. All right, how do we get there to type these in? What button do we even get to the list? Okay, stat, enter, and into list 1 and list 2, we're putting those numbers. I cheated because it takes me so long, so I set all this up. Please be doing this because you have to do this on the quiz. And there really is something to be said for muscle memory, knowing where this stuff is, guys. Haley, please do a couple of these with us. All right. Everybody have 0 through 50, and then these crazy numbers. Proofread your list real fast. 1777, 2502, 3772, 5162, 7113, 9817. Are we good? All right. It says determine a regression equation. Okay, first they want us to look at the stat plot. How do we look at the stat plot? Second y equals, turn the plot number 1 on, make sure it says list 1 and list 2, and then we have to do what? Yep, we have to look at setting up a window. Zoom 9 will do it for us. Okay. Which does this appear to be? Do you remember from those pictures we looked at a minute ago? Exponential growth, or because it's crossing here, right? So exponential growth. So we're going to go stat right arrow. What would that be on our list here? Any ideas? Yeah, it's this exponential regression. Everybody find it? Stat right arrow down until you find exponential regression. Okay. We need list 1 and list 2. If it doesn't already say that, oops. And I would like to store, oh my goodness, really, Hofbauer? How do we store it? Bars, arrow to the right, enter a couple times, Y1 is fine. Okay, then I hit calculate. Now, you may or may not have the diagnostics turned on so that you get the R. The R value is 0.999, so it's really good. Okay, there are some of these that don't actually calculate an R value, and there's another way to do them, and that's the what we're not going to worry about. If we even just look at it, though, is it looking good? Looks like a really good fit. Okay, the question says make a scatter plot. Okay, whoop. I already have one over here. I'm just gonna not worry about it. Then it says find a function to model the data. Okay, we used exponential regression. How do we write that down? Can we talk about that real quick? It says y equals a times b to the x. So you're gonna write down 18, 12. I think I said thousands on there. 0, 1, 2, 8. Got a little crazy. B would be 1.0349 if I went 4 places to the X. Any questions about how I got that from what was on there? Okay. What is the growth rate? This isn't necessarily something it asks on the quiz, but something you're supposed to know about exponential growth and decay. The formula is this, right? So how fast is this growing? They tell me the percent? This became this. So 1 plus what? 0.0349, right? Was added to 1 to get this. So the rate, if we make that a percent, would be about 3.4 or 3.5% is the rate at which it's growing. Already that kind of makes sense? All right. I feel like we did exponential growth regressions before, did we not? I don't remember which ones we've already done because we've done so many. All right, we already wrote the equation down on the last screen, but estimate 2020. So I would prefer you used the saved equation. Now, how do you turn it on to Ask Auto so you don't have to scroll for 3 weeks? It's under second window. Okay, if I put it on Ask Auto, then when I go to the table, 2020 is how many years after 1950? So we're going to subtract 2020 minus 1950 and get 70. And so we get a GDP of almost 20,000, right? 19,951 rounded to the nearest whole number. So we did minus 1950 and we got 70. And then we put 70 in to the table or the equation, and we got, someone read it to me, 19,951. Okay, and I don't teach econ, so I don't know much about what that means. I'm sorry. All right, the next kind we're going to talk about is logistic, and we actually did one of these yesterday. We didn't do a regression equation, but we used a logistic equation that I gave you. It was about bears. Does that sound familiar? Towards the end of class, we did one off the homework. Okay, it says a logistic growth function has this form, and the top number, C here, is called the carrying capacity. Do you remember what I told you that meant yesterday? See, it shows on the picture that there's actually an asymptote, or it actually hits it. So it's the maximum value. That top number will tell us what it's going to max out at, okay? All right, so we are supposed to put in this data. So if you can go stat enter and type in these numbers. You will want to go into y equals and get rid of that last equation that we graphed. And I hope I have mine typed in correctly. Is it 0 through 7? And then like 3 to 9.3-ish? Okay. So if you put them in list 1 and list 2, you're all ready to do your Zoom stat. I did not. And I want to use these again later, so I am going to use a different plot. But I still have to do the Zoom 9. Anybody get this? So it's growing and then flattening out? Everybody okay? All right. So it says to do, find a logistic model. Okay. Now, logistic has the word log in it, but be real careful because it's not the log, it's stat, right arrow, and you have to actually, it's not ln, okay? It's not the logarithmic regression. It is literally says logistic down here at B. Did everybody find it? Now, this is kind of weird because I think this is the one that takes quite a while to calculate on your calculator. I have mine in list 3 and list 4. Let's see if I can do this in one try this time. And I do want to store it because it's nasty to type. You don't want to have anything in frequency list. So just clear that out. Yes, it matters. When I think mine's going to go pretty quick because it's using the power of my computer, but yours may take a minute. Did yours take a little bit? Kind of had to think about it really hard. Okay. It also, notice, does not come up with a R value. All right. This is a mess, guys. Do you see how we have to type to write this down? What does it say? It says y equals C. What is our C value? Yeah, roughly 10. Let's just be lazy and put 10. Over, and then it says parenthesis 1 plus A. What is our A value? Okay, I'm just going to round to like 3/6 here. Remember, it saved the whole thing in my calculator though, so that'll be more accurate. And then it says, I'm looking right here on the calculator screen, it says to put E to the power of the opposite of B, so that'll be negative 0.5011. I'm going to go ahead and leave that 4, but whatever, I don't care. This is your notes. And X. Everybody good with how that's written? Do you need me to put extra parentheses up there with a little arrowhead, anything? Okay. Now, find the value of the model at 20. So 20 years or whatever it is, days, since this was introduced, this original amount. By the way, if I look at the graph, it's doing this. Okay. If I want to know how many of these critters there were out at 20 years in, it's hit the maximum. Did anyone else get the maximum of 10? Okay. I want to know how many they started with, so I'm going to put a 0. Started with about 3 of these creatures, whatever they were. Okay. 5 years in, there was 8, but by 20 years, it has hit the maximum. So the value of the model at 20 was 10. Make a conjecture about why this may fit the data. Let's just write ourselves a note here because it seems to reach a carrying capacity or a maximum where it just like flattens out, okay? So that's what you know when it asks for logistic, is you're seeing something that's flattening out. Everybody good? All right, so these are all the ones we've done so far this year. Okay, we've done linear, quadratic, power, exponential. Big difference here between power and exponential. It's kind of hard to tell, right? The difference between those, the shape is very similar. Logarithmic regression is going to go the other direction. And logistic is if it flattens out at some point. All right. We're not doing all this testing junk. So we're down to example 2. Can you type this one in? This starts at the bottom of 13B, but it carries over to 14A. So I hope you got both worksheets out. So stat, enter. So 2, 4, 6, 8, 10, 12, 14, is that what I'm doing? Is that one? Okay. It says to do the scatter plot. So you guys probably just have to do a new zoom fit because you probably put it in list 1 and list 2. I got to do a little work here. Did everybody get it to look like that? So it doesn't necessarily appear to be flattening, though we could probably use that regression, but it does appear to be growing slowly, yes, towards the top up here. Okay, so there's my scatter plot. And it says suggest a logarithmic, not logistic, okay? So what we need to do, I'm on number 3, step 3, because we're not doing the testing, is calculate the logarithmic regression. And this could be on the quiz, okay? But this is one you have to know from the calculator because it doesn't say logarithmic. Does anybody think they know which one it's going to be? What's the only one that says something about log? No, this is logistic, which is the one that totally flattens out. The only other one that has to do with a log is this ln. Okay, so this is logarithmic, is this number 9. All right, so we're using, what was I using? Can anybody help me remember? 5 and 6 maybe? We'll go with it. See if I get the same answer as you. Then I'm storing it. You guys are still just using list 1 and list 2 because you're way smarter than me. I'm just trying to save myself from having to retype these all day. Did you get something like this? Yeah. That's a nice fit. Look at that R value. Okay. Now it says it's A plus B ln of x. So it's, can I drag this on here? I specified on the quiz, I think I said round to the nearest thousandth. So go out quite a few places. As long as you store it and use all the places, you're fine. Plus B, which is 217.4132, ln of x, which I didn't leave room for. Okay, so there's my crazy equation. If I want to know on day 9 how many computers are infected by this virus, I could trace along here if I was on the actual equation, and it looks like about 1,092, but what we've been doing is just going to Ask Auto and putting in the value we wanted to know day 9, so we have 1,092. So almost 1,100 computers by the 9th day have been infected by this virus. Any questions? All right. So this time I want you to try to come up with, this is number 5. I want you to think about which one you think would be the best model. The ones we've talked about today are exponential, well, you're typing those in, which looks like this, logarithmic, which is growing slower, and logistic, which is generally doing something like this. Okay, so if you're not clear on those, write yourself a note about those are the three that we've talked about today. So this is the brightness of a point of light measured from different distances. So they turned this light bulb on and they measured how many candelas it was from 20 meters away, 30 meters away, 40 meters away, 50 meters away, and so on. So I don't think this is going to look like any of those three, is it? I need to turn my stat plot on to show list. Anybody get this? Does anyone know what that would be? It would be exponential still, but it would be decay. Okay? Exponential decay, because it's all positive. It's just instead of growing. So we're still going to use exponential. Okay? So stat, right arrow, down to exponential. But instead of 1 plus some rate, it's going to be 1 minus some rate. I'm sure you're faster than me at this. I'm trying to change mine here. What am I doing? This is what I'm supposed to be doing, right? Maybe? All right, is that what you got? Okay, so 33 is kind of our original value, and then this is our rate. 0.96 roughly, we'll say, for a minute here. So what is the rate of decay? Okay, so 96% is what's left. How many percent were removed? 4, yeah. If we took 100% minus this, we'd be left with about 4%. Okay, so that's the decay. It's decaying about 4%. All right, where are we supposed to go with this? Calculate the regression, which I just left on the last slide. All right. We chose to do exponential, and it was decay. And our equation would be 33 point, I guess I'll go all those places that I said I would, even though I'd rather not. 0.9563 to the x and the exponent, okay? Estimate the brightness at 100 meters. Not going to be very bright. If you have saved it, you can just go to the table and put in 100. I got 0.38. Did anyone else get 0.38 candela? Questions? All right. So there are actually 2 questions on the quiz. One is like this. I'm going to make you type the data in, and I'm going to tell you which kind to use. It will be out of these 3. What is the word for this one, though? How will you know to? Because I don't say use LNREG. What is the word for that one? Okay. This one will say logarithmic, this one will say exponential, and this one will say logistic. Everybody good? I will tell you what to do. So I will, the second question on the quiz, I get what you're asking. Sorry, I was confused. The second question on the quiz, I actually give you an equation. You just have to be able to type it in right and predict values. It's a logistic one like we did yesterday with the bears. Okay? So this is what your homework is. And then if we have time, we could do one of the homework problems if you want or something. It says you have to do number 2. You can cross off part B. Okay, this is on 14B. Then on 15, I changed it. It originally said you had to do 3, 4, and 5, but I'm crossing off 3 for you. Just do 4 and 5, okay? On 15A, you only have to do 2 problems, 4 and 5. And on 15B, you only have to do 1 problem, the very last one, number 9. Okay, so it's 14B, number 2, 15A, numbers 4 and 5, and 15B, number 9. And if it says like what kind of test and why, just skip that part. All right, anybody have one of those they want to do together, or did anybody actually do any of the application work last night and have homework questions on? I feel like, I think this regression stuff is not that tricky. I kind of feel like we should go back and maybe do something off 11 or 10 with our remaining 5 minutes here. Are you good on Newton's law of cooling? You want to do this icky rabbit problem, which is really not on the quiz anyway. We could talk about these real quick, the pH questions. We could do a half-life. We could do this number 12, exponential regression, but we just practiced this idea. Finance app, need to review that? Yes. Yes. Would you like me to do 9? I think I would really like to do 9. 11. Actually, I feel like we did those numbers on 9. I don't know. But we can do 11 too if we have time. Well, it doesn't look like we're going to have time, but 9 is just, 11 is just like 10, okay? Which I did yesterday. All right. Okay, let's just do that then. That's working for me. All right, number 9. How would that look, guys? Half-life is 1600 years. We're starting with, so we'd have 22 times 1/2 or 0.5 to the T over half-life is 1600. Okay. I'm on 10. Yes, you have this. This is 11A maybe? 11A. All right. How much will remain after 4,000 years? That's just a typing question. Put in T equals 4,000. So I have 22 times 0.5 to the power of 4,000 divided by 1,600. I got 3.89. Anybody else get that? Okay. So the answer that when I put in this came out 3.89 milligrams. And it says, how long till only 18 will remain? This is kind of like the quiz question. So how do we work that backwards? Anybody? Divide first, so we'll get 18 over 22. Then what? I'm not doing this question. I'm just using this space for work. Because the variable's in the exponent, we got to take the log of both sides. So then I end up with the log of 18 over 22 equals t over 1600 times the log of 0.5, but I'm going to need to divide that over here eventually. Okay, so the log of 18 over 22, close parenthesis, divided by the log of 0.5, close parenthesis. Then how do I get rid of that divided 1600 times 1600? I have that it would take about 463 something years. Now, on the quiz, if it said how long until there's less than 18 or something, you might have to round that up. Just plug it back in and see if there's less than 18. If there's not, then you're going to have to round it up another tenth. Any questions? All right, have a good day, guys. Please, 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 it's all worksheets tonight. Do a little practice. Look at the quiz review. Homework questions tomorrow.